Okay, good morning. So today I'm planning on doing this LeetCode problem 892 surface area 3D shapes. So this one, surprisingly, I've never made any submissions for. So I thought I've already solved all the easies, but this one's a brand new one. So I thought this would be a cool opportunity to screen share and see what happens as I try to figure this one out. So I'll plan on doing it in C++ first, and then I'll write it in the other languages. So I already did read the problem statement, and I see that there's these 1 by 1 cubes that are stacked on each other in the z-axis for each ij cell. So since n is fairly small, it's 50, I'll just basically do a simulation, or not a simulation, but just brute force, just add them all up for each cell ij. So I'll basically do a quadratic runtime of n, which should be at most 2500, which should result in accepted, and it's not going to TLE. So let's see what happens. I got my coffee, and here we go. Start jamming on this one. All right, let's just clean this up here real bit. Scene declarations. All right, so this is our matrix, which is basically a two-dimensional array, or two-dimensional vectors. Right, so then we have some kind of value we're going to add on to. So call it area. And here's a good one. Start off with 0, return the area in the end. And then for each I from 0 to m inclusive for m rows and columns here, dot size and a sub 0 size. You have to watch out to make sure that n is at least 1. Some of these old LeetCode problems, they would have an empty matrix with no rows, and basically that just cause a bug when you try to access the column size. Here, thank you, LeetCode. You don't make me do that. Okay, so for each row I, each cell j, basically going to go here and count how much up, right, the top, the bottom, and then all 4 sides. Add that all up. So if a sub I sub j is 0, then we'll just continue. Otherwise, area plus equals 2, top plus bottom, and then each of the sides. So we need to take into account out of bounds as one case, and inbounds is the other case. All right, so let's just write this down here real quick, right? Actually, I should probably start my timer here real quick too. Timer. Well, actually, I don't need to use time. Whatever. I just started to keep track of here. Our minutes for implementation. All right, so the game plan. Game plan is to iterate over the entire matrix, the input matrix A. That is, we will visit each ij cell. All right, so there's case, let's see, so whenever a sub I sub j is 0, there is nothing, right, added onto the area. And then otherwise, +2 for top, bottom of the ij cell. Then add up, down, left, right. Basically, these will be the adjacent cells from ij, which cover the 4 sides, right, which may or may not add some additional surface area, right? Okay, so there's 2 cases, right? Case 1 is out of bounds. Oops, out of bounds. So in this case, if the side is out of bounds, for each of the 4 sides, these are the 2 use cases. Case 1 around bounds, in that case, we'll add onto the area the height of the cell IJ. That's case 5, j, basically. Right. Okay, and then case 2 is inbounds. So here we add onto the surface area the difference between a sub I, a sub j, and the adjacent cell height, right? So if a sub I, a sub j is greater than the adjacent cell height, this is when additional surface area is added. Right, so we should be able to subtract and we don't want to go negative, so we'll take the max of the difference and 0. Okay, yeah, so that's my game plan, right? So let's say 10:40 to 10:43, about 3 minutes for game plan. Right, there's my game plan, and then I kind of already started the implementation. So we'll just keep it at 10:40 for that. Kind of mixed up 2 things, right? Coming up with the game plan and starting coding at the same time. Okay, anyhow, let's do up, down, left, right as UV adjacent to IJ, right? So for UV, and it doesn't matter what these things are called, right? It's whatever, UVI. Actually, I can't destructure a vector like that. It's using pair. Let's do this. Pairs is a vector pair. All right, so pairs up, right. So this would just be clockwise, upright, down, and then left. If U is less than 0, or V is less than 0, or U is equal to M, or V is equal to N, then this is the out of bounds case. Area plus equals A sub I sub J. Otherwise, if it's inbounds, then we'll add onto the area the maximum of 0, and the difference between A sub I sub J and A sub UV, like the adjacent cell. Okay, and then we don't need the curly thingies around here. Okay, yeah, that looks good to me. Let's see what happens. Yay, okay, cool. That one worked. Let's see, 32.46. All right, here we go. Big money, no whammies. Yeah, all right. That's cool. All right, so 10:46. Yeah, I got that done by 6 minutes. Okay, cool. All right, so let's jam in the other languages. We'll post it to the discussion board. Hopefully it's helpful for someone. I don't know. Let's see. All right, a few solutions. And JavaScript. 3. Ooh, I fingered that one. Rust 2. And C++. Bam. Okay. Here's what we got so far. Top plus bottom. I don't know if you want to put a comment here or not. Yeah, I mean, it's a magic number, right? Okay, whatever. Yeah, it doesn't have to be perfect, right? Here we go. Let's go. MN 10:47 a.m. to for meditation, and 3. There we go. So that is the length of A and the length of first row. And then for I in range M, for J in range N. If not, a sub I sub J, we'll continue. Oops. Continue. And then we want the to return the area in the end here. All right, okay. Area. Okay, and then we'll do area suppose 2. It's the top, bottom. And for UV in the adjacent up, right, down, left, if U is less than 0 or B is less than 0 or U is equal to M or B is equal to N, out of bounds, the area plus equals a sub I sub J. Otherwise, if we're inbounds, then area plus equals the maximum constraint to the difference between the current and adjacent cell. Okay, looks good. Yay. 10:49, about 2 minutes for the implementation of Python. It's cool. All right, stick this here. I'll save Rust for last because I kind of suck at Rust. It's painful sometimes. It's going to be painful to watch, so you don't want to go there. All right, here's our matrix. Our arrow will return in the end. Jam on this one and JavaScript. Start at 10:49 a.m. Hour minutes for implementation. Oops. Implementation and JavaScript. All right, so it's mn equals a sub 0. Okay, for 0 as its name, m I for that j0, j is its n, j. If not, I sub j, we'll continue. Otherwise, I'm not very sure we need that. If it doesn't exist, yeah, if it doesn't exist, it's on top and bottom. That's fine, right? Area plus equals 2, top plus bottom, and then check each adjacent UV to IJ. Up, right, down, left. If U is less than 0 or V is less than 0, or U is equal to M or V is equal to N, it's out of bounds. Area plus equals a sub I J. Otherwise, area plus equals the straight, we don't want to go negative here. A sub I J in the adjacent cell would be. Alrighty, big money, no whammies, boom. Okay, cool. 10:51. 2 minutes for implementation of JavaScript. Okay, do Kotlin and Rust next. Alrighty, 10:51 a.m. to whatever it is. Let's implementation. Okay, and pair a size, zero size. So array, and then for I in 0 until n, or j in 0 until n. Launch. If face of I is j is 0, we'll continue. Okay. Otherwise, area. So we'll return here in the end. 62, it's the top bottom. And then we'll look at each adjacent cell UV and list of up, right, down, left, if u is less than 0 or b is less than 0 or u is equal to m or b is equal to n, it's bounds, the area plus equals is I sub j. Otherwise, if it's in bounds, then the area is the constrained maximum. We add on to the area of the constrained maximum of 0, current cell, and the adjacent cell's height. All right, here we go. Okie dokie, looks good. Okay, cool. 52 or 53. It's about 2 minutes. Okay. Here we go. And save the best for last here. First, okay, so that n equals that length, 0 length. That equal area, that's what we're returning in the end here. For I in 0 until m non-inclusive, for j in 0 until n non-inclusive. If a sub I sub j is equal to 0, we will continue. Otherwise, area plus equals 2 is the top, is bottom. And then for each adjacent cell u v in the vector of pairs. I think we can destructure them, but I don't know. Offhand, we'll try. Up, right, down, left, reach adjacent cell UV, adjacent to IJ, up, right, down, left. If U is less than 0 or V is less than 0, IJ, hold on. IJ, that's be a U. I equal I as I32, J equals J as I32. So U size you don't want to subtract 1 from since it's unsigned. U is equal to M or B is equal to N. In that case, area this goes I J. Otherwise, area goes the constrained maximum. I'm going to use C versus max. 0 is I sub j, and the adjacent set is B. Okay. Cannot be indexed by 32. Oh crap. Okay. Yeah, this is what makes Rust a pain. This inflexibility is not convenient for me. Well, let's just do this as I32 here. UV Yeah, let u equals u as u size, equals v as u size. Side 32. Side 32. And then J is a u size. Okay, let's see what happens here. Let's get some 932 found u size. And cast them all to 932. Yeah, this is horribly ugly. That's 32. Okay. Mismatch types. Expected I32 for that thing too. Okay. Oops. This one's right here. That's I32. This guy. This is hard to wrap my head around. It is so painful. This is not even readable. Hold on, let me back out this. I equals I is I32. Ij equals ij. I is I32, and then j is I32. Because I want those to be negative. In that case, it's out of bounds. All right, and then transform as u size, b as u size, and then let I equals I as u size, j equals j as u size. And u size, okay, and as u size as I32, as I32. The index by I32 ij. Hold on. Stick this here. Okay, that's why we saved rest for last. Okay, cool. All right, and that's all she wrote. Let's see, post this guy. And there we go. All right, so Kotlin, JavaScript, Python 3, Rust. Rust is very verbose. So actually, I can shrink that up a little bit. Let's clean this up a little bit, right? Let's just destructure these things. All right, so let ij. We can do this, right? I as u size, j as u size. I wonder if we can stick that in a vector and then just map it, if that might be a little bit cleaner, or if it's just like really hard to understand. Let's do this first. U as u size, b as u size. Okay, a few less lines, a little bit cleaner. All right, hold on. Test cases. Okay. Okay, that's cool. And then another thing I was thinking is we'll just have a vector of ij, which we map to an I32. I32. And then similarly, cast it back to u size here. But it is nice that Rust does allow us to reset these variables, so I don't have to make different names at least. Okay, so we want to use this as a u size in order to access the array. And similar here, we want these to be U size or an access to the array. UV. Oops. Map to those indices, X and U size. Oh. Oops. X is U size. X is U size. Mac exists for this, but they're not due to into iter.map. Into iter. Yeah, something's telling me the previous version is easier to read than this. All right, I think this will work though. Ooh, okay, let's see. Expected closure. Found two. Yeah, okay, that doesn't seem to be working like I wanted to, and it's verbose anyhow. So this is a little bit cleaner. I just destructuring these things on the same line. So we'll post this. Okay. Stick this guy here down under rest. Actually, let's look at this side by side. I think it's a little bit cleaner, but on the line compared to 2 lines. Maybe 2 lines is better. Whatever. We'll just leave it. That's cool. Oh. Whatever. I'll shrink it up. Okay. I'm on the fence. All right, and it's kind of squished in here, but it is kind of not that relevant, especially in the grand scheme of things, algorithms and data structures. It is a coding specific thing. All right, cool. Cheers.